Okay, so right now we are going to be looking at insertion sort, and this will be starting with slide 72. So insertion sort is a type of sorting algorithm where you begin with a section of the array that will be sorted, and then you traverse through the unsorted section of the array, and you grab elements and you insert them into the correct position inside of the sorted array. And so what it looks like is, if you have an unsorted array, uh, initially only the beginning of the array will be sorted. So we'll say that the first element is sorted, and we will be traversing through the array, and we will be moving our pointer. We will be looking at all the elements in the unsorted sections, and we will be grabbing them and putting them inside of the sorted array in its correct position. And so what happens is you have in the beginning you only have a small section of the array that's sorted, and as you traverse, it will more of the array will be sorted, and eventually the entire array will be sorted. And so that's what we will be looking at in our process right here. So this is insertion sort. Right here we have an array of unsorted elements. So we have 0, 5, -3, 7, -2. And I'm just going to assume that you know how to swap variables in CS, in computer science. If not, I can show you later, but I'm just not going to go over it in this because I just assume you already know. So when you traverse the array, what you first do is we're initially just going to assume that the first element, the first part of the array, is going to be sorted. So this is going to be sorted, and what we're going to be doing is we're going to be having two pointers, one pointer pointing to the last element of the sorted part of the array, and one pointer pointing to the rest of the first element of the unsorted array. And we are going to be putting these elements in their correct place. So first, we start off by comparison. So we compare 0 and 0 and 5, and we know that 0 is actually less than 5, so we don't have to do anything with 5, so we just increase our assumption. So we now know that this part of the array is sorted, and so we move our pointers. So this pointer will now point to -3, and this pointer will now point to 5. And then we look at 5 compared to -3, and we know that 5 is actually greater than -3, so these are in the wrong places. So what we'll do is we are going to start the swapping process. And so I'm going to move these back to where they were, and I'm going to do it. So this is the same array, but we're going to start the swapping process so you can see the numbers moving around. So -3 is less than -5, so we're going to swap these two numbers. So this one's going to go in here, and obviously in the beginning the pointers were here, but after we swap it, we also want to move backwards and make sure that -3 is actually in the right place. So we're going to be moving our pointers backwards, and we're going to compare 0 and -3. And we're going to see that -3 is actually less than 0. So we're going to do another swap. So these two are going to swap again. And once we hit the end, once this pointer hits the beginning, we restart our whole process. So now we can increase our assumption, and we know that this part of the array is sorted. And we will be sorting the rest of the array. So yeah, that's the first part of swapping. So after here we have another copy. So we have, after moving -3, this is how our array looks. We have -3, 0, 5, and so we continue our sorting process. So we know that this part of the array is sorted. So now we look at 7 and 5. So we know that 7 is actually greater than 5, so that's actually fine. We don't have to move 7. So now we move our pointers again, and we look at -2 and 7. And we know that 7 is actually greater than -2. So we are going to start this whole, start swapping again. So we start off with swapping 7 and -2. Then we move our pointers backwards. So now we're looking at 5 and -2. And we know that 5 is actually greater than -2, so we keep swapping backwards. And we're going to move our pointers again. And we look at -2 and 0. -2 and 0. We swap these again. Then we move these pointers again, and we look at -3 and -2. And we see that -2 actually is greater than -3. So we're done here. So we go back to looking at the rest of the array. We can assume that this part of the array is sorted. And we look, and we're actually at the end. So we're done here. So the finished product it looks like this. We got -3, -2, 0, 5, and 7. So now let's look at coding this up. So just to rehash, what we just did is we're grabbing the last element of the sorted section of the array and we're comparing it to the first element of the non-sorted array. And we are then grabbing the unsorted elements and we're placing them into the correct position among the sorted array. So let's code that up. Let's go opening up VS Code, and my language of choice is TypeScript, so I'll be using TypeScript. If you want me to use a different language, I can do that. It's fine. This is just what I use at my job. So let's call our function insertion sort. And we are going to be taking in a number. So this is going to be taking in a number. Why is it yelling at me? That's annoying. We'll call it insertion capital I. Just yelling at me for duplicate names, but it doesn't matter. So first, what we're doing in the array is we're going through each element, right? So let's make that part of our code. So let's write up our for loop that goes through all the elements of the array. Let's do for let I is equal to 0, I less than nums dot length, I plus plus. And so obviously this is going to be looping through the entirety of the array. And we're also going to be having another pointer, which we're going to be using for comparison reasons. So as we loop through here, we want the other pointer to actually be at the same place, but we're also going to be looking backwards. So that might be a little confusing, but just keep along with me. So we're going to copy I, because that's what we do. And then we're going to make another while statement. So while j is greater than 0, so we don't want to go index. We keep this statement because we don't want to go index out of bounds. And the previous element is greater than the current element, we want to be doing swaps. So in this case, that's what we're doing is we're essentially checking if this number is less than this number. So if this number is greater than this number, then we need to be doing swapping and we need to be looking backwards. So that's when that while condition triggers. So let's do that. And so now let's do a swap. So we're going to do swap. So let's first make a temporary variable at nums j. I said jums. Nums j. Let's do nums j. We're going to be swapping with the previous number. So j minus 1. Boom. Nums. I cannot type today. What is going on? Nums j minus 1. J minus 1 equals temp. So right here we just did a swap, and then we just decrement our pointer because we also want to check the rest of the sorted array. So we want to be after we do this. After we do our initial swap, where remember again. After we do our initial swap, where we swap -3 and 5. You know, from here to here, we also want to look backwards. So we want to move this pointer backwards, and then we want to move this pointer backwards. So that's where the j minus 1 comes from. So after we code that up, that's actually it. So then at the end of it, at the end of the for loop, we just return nums. I'm a curly brace out. After the for loop, we just return nums. And I'm going to be breaking out the debugger and going through this line by line with you. So, but first, let's just make sure that it works. So let's test it with the array that we were looking at in the example. So 5, 7, comma 2. And we're calling it insertion sort. All right, so let's go bun, and then I'm using bun to run TypeScript files, but this doesn't really matter. So just don't be too confused, but this is just how you run the code. So we run bun playground tests. This is wrong. This is not it. I messed up somewhere here. And let's see, where did we mess up? Did I? Oh, this 2. Okay. I was scared for a little bit. This 2 is actually supposed to be a negative. Okay. So then when we run it, we can see that we got -3, -2, 0, 5, 7. So we know that this algorithm works. So let's break out the debugger and let's just run line by line and see what we can find out. Debug bun. Let's start some breaks. So we're gonna make a break here, and let's do a break like here too. So we're gonna be looking. We're gonna be looking at each element. We're also gonna be looking at the temporary when we do swaps, and then we're also gonna be looking at the decrements, like when we move the pointer back. So let's activate the debugger, and we can actually see what the code looks like. So we just look at the array right now. We see 0, 5, -3, 7, -2, and we go, you know, in the first case, we start off with I. You're actually supposed to start off with 1, but it seems to work fine. So 1, obviously, we don't do anything. We don't do any comparisons. Let's actually add a breaker here. So in the second position, you know, we're comparing 5 and 0, and obviously it doesn't do anything. But in the third position, we are going to be swapping 5 and -3. So as you can see, the nums did get swapped. Let's just do line by line. So let's just step into, instead of using the break lines. So then we decremented j, so now we're going to be looking at 0 and -3, and obviously we know that 0 and -3 need to be swapped. So if we step line by line, we assign the temporary variable to -3. We overwrite the position, the -3 with 0. So yeah, it becomes 0, 0, 5, 7, 2. But then we also have to set the previous element to the temporary variable. So that becomes 3, 0, 5, 7, 2. Let's keep running this. So this is 5 and 7. 5 and 7 is fine. So then we check the next one. Then we check the next position. And now we are actually at -2, I believe. This is where we... no. 3. So we'd be 0, 1, 2, 3. Yeah, no. I messed up. My bad. Then we get to, yeah, at 4, this is where we're checking the -2. So 0, 1, 2, 3, 4. And we're checking -2 compared to 7. So you can see here, 7 gets compared with -2. And so now we need to assign our temporary variables. So we can see temporary, 2 gets assigned to the temporary variable. And now we need to do the swap. So we swap 7 and -2. We write 7 to the last position, -2 to there. And we can just keep running through this and seeing the process. So as you can see, we do a bunch of swaps. And eventually we get our answer. And that's pretty much it. If you have any questions, let me know, and I'll be happy to help you out. I obviously made some more tests so we can run the test, and I tested it with some other arrays. But I believe that's enough for you to make a good judgment. Thank you for your time.